The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome to today's webinar, Piping and Cabling in Creo 3.0. My name is Rob Romanowski with 3HTI. I am the Director of Operations for 3HTI, and I'm joined today with our Senior Engineering Director, Mr. Bruce Bodnick. And what we're going to do is we're going to give you an overview of what the piping and cabling extension is for Creo 3.0, as well as giving you a demo of piping and then a demo of the cabling capabilities with this extension. I'm going to allow Bruce to do that because if I did it, it would be ugly. So anyway, a couple of housekeeping items before we get started. Everybody is going to be on mute throughout the presentation demonstration. If you have any questions at any time, please open up the question box in the dashboard and type them in. We will answer them at the end, but if it's relevant to what we're discussing or while Bruce is presenting, we will try to answer those questions during the presentation. Also, I am going to upload a piping and cabling extension brochure, PDF brochure, into the handouts slot. I have not done that yet, but I will. So check for that during the presentation, and then you can have that information. So it's going to be an overview today. So if you want to see something more detailed, specific to what your needs are, just let us know, and we'll do a private custom demonstration for you. I mean, the purpose of this is for people to just get a get more of like a 30,000 foot or maybe even a 20,000 foot view of what this product is and what it does. But we're more than happy to spend a little more time with you and go into some more detail specific to your needs. So just a couple things about 3HTI, because we do have quite a few customers on the line today, and also see some names and registrants of people that I don't recognize. So just to let you know, we are a systems integrator of various software and hardware solutions, but actually we're in the innovation business. That's really what we do. We help companies in discrete manufacturing innovate and improve their competitiveness related to product lifecycle management by providing a myriad of technology solutions and services to help them adopt and maximize these technologies, allowing these companies to develop and manufacture products better, faster, more cost effectively, and ultimately improving the profitability of their business. Hopefully it's helping people live better lives, because ultimately that's what we want to do all the way around. So just a quick snapshot of our product portfolio. We are not a peddler of software or 3D printers or anything of that matter. Our solution offerings are focused to help companies become more effective and competitive. And what we want to do is help solve your problem. We want to fall in love with your problem and provide a solution for it. So we offer various 3D printers for manufacturing, such as the Markforged line of 3D printers, which print in carbon fiber, as well as Kevlar and fiberglass. We also represent actually, I made a mistake. This is an older slide, but we recently became a reseller for EnvisionTech, which provides very high-level precision 3D printers, as well as bioplotters to help print cells and soft tissue. We also offer a myriad of analysis solutions from Mentor Graphics, and also we are a reseller for a product called Simulia, which was formerly known as Abacus. And also we are a PTC reseller specializing in CAD software as well as product lifecycle management solutions within the Windchill suite. And here's a list of some of our customers, and actually a couple of these names are joining us today, which is exciting. As you can see, some of these companies are pretty large, but this isn't to be a slide to say, here's the who's who of 3HTI, who we do business with. But basically, the point is that we, through our experience dealing with a lot of these different companies of various sizes, their problems are similar, but their problems are also very unique. So I guess the point is, by showing such a wide range of customers, is that we've seen a lot and we've done a lot, and we're well equipped to handle many different problems that you may be experiencing, and just basically be a good partner, a trusted partner to help you solve those problems and get your business to the next level of where you want it to be, and help you reach your manufacturing goals and your company goals. So the Creo piping and cabling extension. So what is it? So basically, engineers and designers require integral capabilities to design and optimize the routing of electrical and mechanical systems. The Creo piping and cabling design extension automates the creation of 3D routings and the associated manufacturing deliverables. Cable and pipe routes are easily defined and automatically validated, referencing 2D schematic logic. This helps to determine the optimal route for piping and cabling, connecting the electrical design process to the mechanical design process. Now, without the piping and cabling design extension, designers and engineers are relying on physical routings or third-party solutions. Physical routings must be created late in the product development process after physical prototypes are created. Routings are defined too late in the product development process to accommodate rework and design, and as a result, companies that create physical routings are rarely able to optimize manufacturing, cost, and serviceability. And due to time and effort, the accepted route is typically the first one that works rather than the one that's the most optimal. Another problem associated with physical routing is incomplete, inaccurate, or even missing documentation. Without 3D routing information, engineers and designers are unable to visualize and avoid errors due to design and routing conflicts. Now, third-party routing solutions present similar challenges for engineers and designers. Similar to the issues with physical routings, third-party routing capabilities are typically not used until late in the process when designs are near completion. Due to restricted time and budget, redesign and rework is typically avoided, and routings are rarely optimized. And third-party routings do not update when geometry is modified, resulting in errors and rework. Using the Creo piping and cabling extension, engineers are able to rapidly define 3D cable and pipe routings and create accurate manufacturing deliverables. The Creo piping and cabling extension also supports schematic-driven design. Using schematic design capabilities, the first step is to first define 2D cable and pipe diagrams. Step 2 is to define 3D routings referencing 2D schematic logic for connectivity and pipe fitting information. The next step is to optimize 3D routing information using drag handles on the fly and editing to manipulate cable and pipe routings referencing 3D assembly geometry. Verification and validation is easy using electronic verification capabilities to compare 3D information against 2D schematic logic. The 3D routings are directly utilized to create high-quality manufacturing documentation. Information is automatically extracted to define a wide range of downstream deliverables. So what I would do now, I'm going to skip these other two slides. I'm actually going to just go right to demo time and let Bruce Bruce give you a presentation on the capabilities of the piping and cabling extension. So Bruce, I'm going to make you the presenter.
All right. Thank you. Good afternoon, everybody. Let me share my screen and move this out of the way. Okay. All right. So basically, we're going to start with a demo of piping first, and basically then after that's done, move on to cabling. Now, to start, I'm going to open up what's called Creo schematic. And what we're looking at in Creo schematic is the front end that Robert remarked. It's basically a 2D schematic routing package or layout package. It's basically just a 2D drafting package that allows you to lay out schematic diagrams either for piping or cabling. Now, in this case, we're looking at piping. And basically, each of these graphic elements represents a particular type of element in the piping design. This R1 here, this is a reducer. If I would actually select this object, I could actually go ahead and look at its properties. And basically the properties tell me it's a reducer, get some information about it. More importantly, it's actually associated with a Creo parametric solid model. Okay. So this schematic currently is laid out for three legs, and we want to actually add a third leg or a fourth leg, and that's what I'm going to do right now. So the first thing we want to do is we want to create basically a leg for this pipeline that runs from this IC6 into this pipeline here. To do that, I need to place a T on this pipeline, so I'm going to go into what's called my Catalog Explorer, which basically is a catalog of all the types of elements that I can add. And I'm going to basically add in a welded teeth into this pipe. And basically, let's put it right about here. Okay. Once it's there, I'll go into the properties of it, and I'm going to go in and apply a data set and tell it what size it is. And once it does that, it comes out here and gives it a name. And now I'm going to go and route a new pipeline. So I'm going to go into my catalog again, go into my groups and pick pipeline. And now I'm just going to route a pipeline from here, and I'm just going to bring it up to this location. Looks good. Exit out of the tool. If I then I'm going to pick this pipeline, go into the properties of it. Notice the size of this is currently unset, and I'm going to tell it to calculate the value, and also with the spec. And when I do that, oh, I have to do one other thing. Let's go and change the label color. And let's make it black, and let's make it a little bit larger. All right, so notice as soon as I did that, it picked up the size of this pipe from the size of this element over here. Now, we want to add, basically we're going to kind of duplicate what's done on these legs. So we're going to add two reducers. So I'm just going to go into another way to get it. I can pick up a reducer by going into my Catalog Explorer, or I could actually go into my blocks here and tell it I want to pick up a, in this case, we're going to do a flanged reducer, concentric. Okay. And we'll, oops. Okay. And we'll just come and drag and drop it right about here, and then we'll drop one about here. Okay. And now I'm just going to go back into each of these reducers and go into the properties of it. And I'm going to apply a data set. Now, I want this to be go from a 150 size. In this case, I want to go down to an 80, and I'll just apply that. Okay. And notice if I update my labels, this has now become an 80 size pipe. And I'm just going to come in here, go into the properties of this, go into the apply data set. The size is going to be an 80. Okay. And we're going to go down to a 50. Apply that. When I update the labels, now notice that this has become a 50. We're now going to add two valves. So I'm going to add these valves. I'm going to go ahead and go into my blocks. Let's go ahead and expand the valves guide. I'm going to add a gate valve and drop it about here. And I'll go back to my blocks and pick in this check valve. Okay. Notice it very quickly kind of flashed up a little cyan circle. That's an indication that it's going to consider those two valves to be butted together. I'm not going to the properties of each one of these, and I'm basically applying and tell it what size. So 50 here. Oh, one other thing is let's go ahead and set the valve number. So I'm going to set the valve number to be valve 1 of a set of 2. in other words. Properties here, again, make this a 50, and come down and make this a 2. All right, so that's good so far. Now we also want to add in a segment that goes from this 150 over to this entry port on the cabinet here. So to do that, I'm going to go into my fiber icon, and I'm going to route a pipe. And I'm going to come up here and notice the cursor changes to sort of looks like a T. That lets me know that's going to actually put in a branch at that point. And now I'll just drag this pipeline all the way over to here. Exit out of the tool. Okay. Now, it knows that this leg is part of leg 4. So what I need to do is I actually have to take this guy, and I'm going to basically reparent it and tell it to add this leg and make it part of leg 4. Okay. I'll then come in here and zoom in on this, select this, and go into the properties of that T. And basically it's going to be, I'm going from a 150 to a 25. Okay. Now, as soon as I do that, if I kind of update my labels, this has become a 25. And now finally, to finish this, I need to add a reducer that goes from 25 to 15. So again, I'll go to my blocks, reduce this. Let's bring up a reducer and plop it in here. And this reducer is going to be, let's see, starting with a 25 size, and we're going down to 15. So at this point, I could move, it looks good, and at this point, I can come up and say export, export this data from this Creo schematic into, I can give it a file name, tell it I'm going to just export the sheet, and just say OK. All right. At this point, I'm going to go into Creo Parametric, and here is the Creo physical model that's been partially done so far. And what we're looking at are the 3 different legs that have been previously created. And what we want to do is actually create this 4th leg that I just created in the Creo schematics. So to do that, I'm going to go into under Applications and activate piping. And now I'm going to go into the pipe icon here. And I'm going to read in this working from my working directory under, let's see here. Open up this XML file, and I'm interested in leg 4 that's in that file. And I basically want, it's actually going to create a new assembly for me. And I'm going to change this to my assembly view. Notice I actually have a leg 1 assembly, 2, and 3. So I want to create a new assembly in this piping assembly. And it's just going to be called steam leg 4. And I'll hit the OK. And that creates a new pipeline. Okay. Now at this point, I'm going to go into operations here. And I'm going to go into a designation. And for pipeline 4, I'm going to pick this pipeline. And notice that it knows that that pipeline has 2 pieces of equipment attached to it. And it actually matched those up to things that are already in the Creo Parametric assembly. But under the fittings, notice there's a whole number of fittings that are missing. And these fittings came from the Creo schematics XML data. So it knows they're missing, and it's those fittings are not physically in the design here. Okay. So what I'm going to do is I'm going to start routing a pipe. So I'll just basically create a pipe. I'll turn on my coordinate systems here. Oh, I'm sorry. Route a pipe. All right, so I'm going to start the route pipe icon here and pick a start point at this coordinate system, okay, which puts a little circle there. And at this point, I'm going to do an extension and extend it along a coordinate system. And actually, I'm going to extend it referencing this coordinate system and this guy with an offset of 0. So it's basically just going to create a pipe from here all the way out to basically this location. Okay, and I'll just hit the OK. And notice because I have my thick pipe display on, I get an indication of the size of that pipe. I could turn it off and just look at the thin pipe display, but we'll just do it that. All right, at this point, we know if I had my Creo schematic design, I know the first thing we want to add is a reducer on this. So I'm going to insert a fitting and basically pick a location on the segment and pick a reducer. Now, notice the first reducer is R1, which is an 80 reducer. And I'm just going to change this dimension to move it a little bit closer to the start. And I'll basically apply that. And it added the reducer, and it also decreased the size of this segment. I'll now add a second reducer by picking a new location. And notice it automatically switched to R2 with a new size. And again, I'll go ahead and bring that, hit the OK. And notice it reduced this. At this point, we want to basically add a group fitting. If you remember, our gate valve and our check valve were butted up against each other. They're considered a group. So I'll pick a location where I want it to go, and notice it picked up the gate valve for me. If I go into the placement and orientation, I see that the valve is oriented incorrectly, so I'll rotate it. And I'll also specify a distance of 500 to move it a little bit away. I'll go back into the selection, and using this button, I'll go to the next item in the group, which is the check valve. And again, if I go into the placement, and I'll rotate it 90 degrees, and I'll just hit the OK. So it places those two valves on that pipeline segment at that location. All right, next thing we're going to do is we need to finish the routing of this pipe. This pipe is going to be extended up to here. So we're just going to select route pipe. Notice it puts a little circle here. And now we basically want to branch it up to basically this location on this pipeline. And I'll just change the angle to 90 and just hit the OK. That gives it to me there. And lastly, we're going to route the small pipe that goes from here up to over to here on the cabinet. Okay. So to do that, we're going to go and set a start point on this location, and we'll specify a ratio of halfway along it. And I want to specify a size of 25. Hit the OK. At this point, I'll do some extensions. So I'll extend along the Y. Nope, I'm sorry, X, and I'll bring it up 300. Apply that. Then I'll move it over to Y a little bit. Take it there, apply that. Now I'm going to go down to next, but I'm actually going to say offset from reference to here. 0, apply that. Then I'm going to go into the Z direction. I'm still offset from reference, and I'll say offset from that. In the, let's see here. Somehow it didn't get. There we go. There. There. Apply that. And I'll go in the X, offset to there, and I'll hit the OK. And lastly, I'll come in here and say connect it to this guy. So that puts up there. All right, we do need to add a reducer here, so I'm just going to go up here and add a fitting. Pick here. And this is going to be a reducer. I'll just put that reducer there and then cancel out of it. And let's see here. We'll come over here, pick this, insert a fitting at this location. And this is going to be a, let's see here. Well, let's just make it that. Well, I'm not sure if that's the correct one. Let's go ahead here and let's do another fitting here at this guy. That is going to be a insert. Let's see here. Cancel it. Insert fitting at that location. Can't find it. I'm not sure why it's not lying there. But anyway. All right. But anyway, let's say that's what I wanted to do there. Let's do a key up here. Let's insert fitting. Let's do it. Key. This leg. And apply it. And then hit the cancel. So notice I put the T there. All right, if I was happy with this, I could reactivate it. And now I could then start doing the drawing and create a drawing of this. All right, at this point, let's move on to the cabling. And to do that, let's just close out of this and erase not displayed to clean out my memory. And come into cabling. And, set that to be my working directory and open up this charging assembly. So basically what we're going to do is I'm going to basically hide this part, and what we want to do is we want to basically do a little cabling and connect some, add some connectors to this thing and then wire it up. So the first thing I'm going to do is I'm going to basically create a new assembly, and I'm going to call it cabling, for lack of a better name. And we'll just browse and pick up this as my start assembly. And now I'm just going to locate it at the default location. I'll go ahead and activate it. And now I'm going to use what's called shrink wrap. And I'm going to create a shrink wrap feature in this new assembly that I created. And I also want to pick up some references. Some actually coordinate systems that are located in some of the parts that are already in the assembly. So I'm going to pick up these 4 coordinate systems from the base part, and then I'm going to pick up this coordinate system from this part. Now, what I just did, now let me open up this cabling assembly by itself, and that's the one I just created about 30 seconds ago. And basically what I did, the shrink wrap feature basically copied a number of surfaces from the parent assembly into this subassembly along with these coordinate systems, M1, C2, and if I actually turn off shading, I see that what I'm looking at is actually not solids, they're surfaces. So I basically created a very lightweight assembly, which is kind of a good idea. So you don't have to mess with your original assembly. So it rotates and you can work on it a lot easier. All right, at this point I need to assemble in some connectors into this. So I'm just going to assemble, and I'll pick this CON2 connector. And I'm going to locate it at this coordinate system and then a new location over here. I'll then assemble in another connector, this for the lamps, and I want it assembled here, new location over here. And lastly, I'll assemble in the 9-pin connector and put it right there. All right. At this point, let's go into applications cabling. And the first thing I need to do is I need to create what's called a harness part, and that's the part that the wiring harness is going to go into. So I'm going to create a harness. Try to spell it correctly. And I'll just do a browse and pick this as the start part and just hit the OK. So it creates a part in here called harness. And now into the view very quickly, I'm going to go into my appearances manager, and I'm going to load in a colors file that has some predefined color definitions. These colors have 3-letter names, and they match up the 3-letter names that are in my wire definitions. So I'll know my colors will come out correctly. All right, before we start, let's go back into the cabling. Before we start actually routing wires, we have to designate these connectors to be basically connectors with entry points. So I'm going to do a manual designation and basically pick up this guy, and I'm going to specify an entry point to be this coordinate system. I'm going to tell it that I want, when I route a cable, I want the cable to go 2 millimeters inside the connector. In this case, I want the wiring to be laid out in a flat orientation. Okay. I've just turned on my reference designator, and basically notice it gives me this little message here, or this little 3D note, that this connector has been called back. I'm now going to go ahead and to designate these other 2 entry points. Now this one has 2 entry points, so I'll grab both of them. I want, again, an internal of 2, and I want a grouping of round on this one. And lastly, I'll come up and grab this one. Designate it. Entry point's going to be this one and this one. 2. Round. Done and done. All right, once I've done that, the next thing I'm going to do is I'm going to start the route. Before I do that, let me zoom out of here. I'm going to go into the cabling parameters of this guy, this guy, this guy. And basically the reference designator that was assigned to him was this long string. And the reference designators that are used in the Creo schematics is just simply C-01. And for this one, it's L-01. So I'm just manually changing these reference designators to match what's in the Creo schematics because I'm really doing manual routing right here. All right, next thing I need to do is basically go into read in some spools. Spools are basically where you're going to pull your wire from, and we already have some spools predefined. I'm going to use the 16 black, the 16 red, 14, I'm sorry, and then these 2 here. So I'll just, now if I edit one of these spools, I'll just pick the red one. Basically what the spool is, it's basically, this is showing me a definition of the wire, what its name is. It's a wire rather than a cable. If it was a cable, I'd have multiple connectors in it. It's telling me what the minimum bend radius is, the thickness of the wire, so on and so forth. Okay. So now I'm ready to do some routing. So let me actually go into my, well, let me stay in this view. I'm sorry. To do route cables, I'm going to click on the route cables, and I'm basically going to pick 4 wires, or create 4 wires. And this first wire I want to use pull wire off the red spool. For W2, that's good. We'll keep that on black. Wire 3, we're going to use 16 blue, and we're going to use 16 gray for wire 4. Now to route these, I'm just going to basically pick this guy, zoom out here a little bit so I can see my entry points. And I want, again, I'm manually routing my wires from basically, click here, zoom up, this entry point over to entry point 1. And that's what it gives me. I'll apply that. And let's just turn off the cable display for now. Now I'm going to route 2, likewise from this entry point. In this case, we want to use entry point 2. Apply that. Now in this case, I routed them both individually. I could route 2 wires at a time. So at this point, I'm going to take these 2 wires and pick this entry point and move them up to here. Okay. Now if I turn on my thick cable display, I see I have a slight problem. Okay, because first of all, these 2 wires are going to the same entry point here, and I want them to go to different ones. And also, these 2 wires go through this little rib, and that won't work very well. So what I'm going to do is I'm going to first I'll fix this guy up. I'll select this. Let's go back in my thin cable display. I'll pick this guy and basically go into. Let's just go route cables, wire 4. And instead of going to entry 1, I'm going to pick entry 2. So that just changed that. I'm now going to go into my, let's go into my top view so I can things a little bit easier. And now what we're going to do is we're going to reroute how I did it. Because by default, when you manually route, it just puts the wire from the start point to the end point. So what we're going to do is pick this red wire, and I'm going to insert some locations for it. Now what I'm doing is I'm digitizing some locations, and it's actually placing the wire at offset a certain amount from the surface that I'm picking on. Okay, and it's offset by the diameter of the wire plus some little amount. Okay, so now I've basically rerouted that wire, and I'm happy with it. And what I'm going to do now is pick this black wire. And instead of kind of picking locations, I'm going to use this reroute it and tell it to follow the route of this cable from this location up to this location. So once I do that, now I can say I'm okay. If I turn on my thick cable display, now there's my manual routing. Now this side we're going to we want the same wiring. It's going to kind of pretty much look the same way, but now we're going to do it with the XML. Okay, we're going to do what's called schematic routing. So to do that, I'm going to basically read in my schematic data. So I'm going to import. Now you can, we're going to bring in from Creo Schematic an XML file called this guy, and hit the on return. So it read that in. Okay. At this point, we'll go through an auto designation, and notice C1 was the one we manually designated, L1 we manually designated, and M1 we manually designated. However, the system automatically matched up CO2 with the solid model that was in the system, and L2 with, again, the solid model that was in the system. So it automatically designated those, and it automatically created that LO2 and CO2 for us. Okay. We're now going to kind of update our design. We want to basically update everything, and now we want to kind of compare the difference between what's in logical data, meaning what's in the XML data, to what's in the solid model. And notice that at the top of this information report, wires 5, 6, 7, and 8 that are coming from the XML data do not currently exist in the assembly. Okay. Likewise, if I scroll down to the bottom, there's some missing spools because I only brought in the 4 spools I needed for these 4 wires that I manually routed. All right, so we know we have an issue. So what we're going to do is start routing things. So I'll go into my route cables. I'm going to do a find, and notice it actually found those 4 wires that need to be routed. And we'll just pick these 2 and add them to items to be routed. And notice it automatically knows where they're going to go to and from. So now I can just apply that. We're now going to do another find and pick wire 7 and basically apply that. And then hit the OK. Let's go ahead and insert some locations similar to how we did on the other one. To have it route around maybe the way maybe in a better way. And I'll just go back and route cables. The last one we need to route is wire 8. Okay. Now, rather than using the simple route, I'm going to basically change this to follow cable. Tell it to follow this one from this location up to this location. Okay. Now when I go to my thick cable display, that's what it looks like. Now the next step in the process is to actually create a wiring harness. Before I do that, I'm going to quickly go in and pick these locations where the wires are going through, and I'm going to set their grouping to be flat and oriented 180 degrees. They won't look any different in the assembly here, but when I do my flat harness design, it will cause them to appear correct in the flat harness layout. So I'll just pick those locations, okay, and then go into the properties of those locations. I want them to be flat with an angle of 180. Now again, nothing will change on the screen, but when I do my flat harness, you'll see a difference. At this point, I'm going to come up and create a new Creo object. It's going to be a manufacturing harness assembly, and we'll call it harness_MFG. And it needs to know basically what wiring harness this flat is going to be associated with. So I'll pick up the harness part that's in memory. I haven't saved anything to disk yet. Okay. And now it needs to know a name for a subassembly that's going to create, that's going to hold the flat that we're going to create. And I'll do a browse and pick up this guy to start. And basically what I'm in this wiring harness. Now let me move over here, and I'm going to go ahead quickly and temporarily change to a dark background. And notice I have 2 windows. In the smaller window, I have a view of this wiring harness in the form state. And my flattened harness is going to be shown in here. There's nothing in here yet because I haven't really started the flattening process. So to flatten out this cable, I'm going to basically first go into the layout, and I need to set a start point. So I'm just going to zoom in here and tell it I want to use this as the start point on the 3D harness. And now I'm going to go and use what's called an auto fan out with a radius of 5. So basically what I'm doing is creating sort of a nail board drawing. Okay. At this point, I can minimize my sub window and notice it actually laid out that harness nicely. I'm going to go into the orientation, make it a vertical orientation, and done quick. Okay. I'll now go and do an automatic regeneration, and it regenerates the flat for me. I'm now going to, let's go ahead and before we go ahead, let's turn on this. Let's go into the view. Let's create a front view. So I want this to point to the front, this to the top, So that basically created a view orientation, so if I ever rotate this out, I can come back in here and pick front, and it'll reorient me that way. All right, now let's turn off my plane so I can see things a little bit better. And notice that while it did flatten it out, they got things crossing over each other. So I'm just going to go into flatten, move segments, and just grab and start dragging these segments around. And I'm just trying to move them so they don't cross over each other. Something like that. All right. Once if I'm happy with it, then I can go into my components and assemble the components. I'll just say assemble all. And if I zoom up, notice it put the connectors on the ends of those guys. This one is basically in the wrong orientation, so I'm just going to redefine this guy, and I'm going to orient it. Use this guy here, and I'll turn on my planes and tell it to there on the yellow. So what that did is just reoriented that connector so it's parallel to my viewing plane. And if I wanted to, I could maybe do the rest. Okay, so I could kind of redefine this guy, and I could maybe specify an orientation angle of 180. Okay. Let's turn off the planes. Let's move segment. And just kind of put those on top of each other. Now, if I do move these segments over here, close in here, and now I could actually go ahead and go into the components, and I could say fan out this guy, and the fan out basically will adjust the length of here so that it will actually match up with this guy. So I'll tell it, fan out this guy, let's fan out this guy, and let's maybe fan out this guy. All right. All right, assuming I'm happy with that, let's, and notice I could go to thick cable display and see it like that. No, somehow, what happened here? Let's go back in and flatten component, define this. Done. Okay. Done return. And I'll just do regenerate automatic. All right, if I'm happy with that, the next step in the process is to create our drawing. So I'm just going to go back out of here, and let's go open in session. Let's go back to our charger assembly. And now I'm going to go up here and say, let's create a drawing. And let's go ahead and browse, working directory, empty with format. And I'm just going to right click here, general view, and pick this guy here. Okay. All right. So there's that guy. I'm going to come in here and let's go into drawing models and let me add my harness part, or actually the harness flat assembly. And let me change my background colors back to the default so we can see things a little bit better. All right, now I'm going to add a new view for the flat harness. Let's apply it. Just change the scale. 0.75, apply that. And I can make scale that one up. And if I wanted to, I could go back to this guy. Down here a little bit, move this away. Okay. Maybe I haven't scaled up a little too much, but that's okay. At this point, I could, let's go into annotate. I could say show model annotations here. And that would turn on and show me these reference designator tags. And lastly, I could add some tables. And before I do that, let me go back and add the harness part to this model. Once the harness is added, I can add various tables, and we actually have a table predefined. And I can plop a table on this drawing. And there's various tables. This table was created with something called Pro Report. It's part of the Creo drawing package and allows you to create various tables. Here we have a wire run table showing the wires, what spool they're coming, what the wire is going to and from, what spool they're coming from. You could also generate tables that would summarize the lengths of all the wires and tell you how much wire is coming off each spool, so on and so forth. All right, at this point, that's kind of basically it. We'll, I guess at this point, Rob will open up the floor to questions.
Yes, indeed. Bruce, nice job. So if anybody has any questions, please type those into the questions box in the dashboard. If you'll notice in handouts, I have uploaded the PTC Creo Piping and Cabling Extension PDF brochure. And what I'm going to do is I'm going to take control back. I want to share with everyone a couple of other quick slides pertaining to the presentation. There we go. So PTC is running a special for this quarter through December. Now, usually orders need to get in a little early to make sure that everything flies through. So we're kind of asking people if this is something of interest that we can wrap everything up by the 22nd of December. So the piping and cabling extension for which we just demonstrated to you falls under a package, special package for Creo called Creo Essentials Premium. Now, real quick, also included in Creo Essentials Premium are standard linear static analysis capabilities on not only parts but also on assemblies. This does automatic meshing and solution convergence, and basically the whole idea behind this tool is to keep it simple and give the capabilities in the hands of your designers and engineers so that if you do have an analyst that's going to measure this downstream, that basically that person is verifying what was done in the design and engineering process so it doesn't have to be reworked. And this does not do thermal or nonlinear simulation. That's not included in this package. So basically this package is $1,300 off the first year of an annual subscription, and that discount also includes the yearly support. You can save over $3,000 on a new perpetual license. And the third route would be if you are an existing 3HTI customer, we could talk to you about an incentive for adding piping and cabling to your current license. So I'd like to thank everybody for attending. If you have any need any additional information, or you'd like to see a demonstration specific to your needs with a part or an assembly that you have, we'd be more than happy to set that up for you. So you can contact your 3HTI sales representative, or here's my information if you want to contact me directly, or shoot us an email at info@3hti.com. We'd be more than happy to help you solve whatever issues you may have. So once again, Bruce, thank you very much for an excellent demo today, and I want to thank everybody who attended. I will have this webinar recorded and available for you to view at your leisure again early next week. So thanks again, everybody. There's no questions, so we're going to dismiss everybody. Thanks for hanging in there with us, and have a great day. Take care.